Okay, now let's look at the worked examples real quick. We'll just quickly remind you that when we had cos A plus B, okay, and we said this was equal to cos A cos B minus sine A sine B. Right, so what I'm doing right now is what I would suggest you do if you get to an example, to an exam that we have questions like we'll see just now. First thing you're just going to try to do is write the trig identities or write the compound angle formulae. Okay, we now have of cos A minus B. This we said was equal to cos A cos B again. So anything that's for cos is cos A cos B and then sine A sine B. But here when it's a minus in here it becomes a plus. So it becomes plus sine A sine B. If you write this, then you can be able to develop the first two. By first adding, you can add them and you know that cos A plus B plus cos A minus B will be equal to, we know that this negative sign and this positive sign will go, they have different signs, but this will become 2 cos A cos B, right? So it will become 2 cos A cos B, but I'm going to just write cos A cos B because we would take the 2 to the other side and it would become half, multiplying the whole thing that's on the other side, which is this one. So, and for the other one, we know that now we are putting a minus, right? If we put a minus, we would have cos of A plus B, then minus cos of A minus B, right? And let's see what this becomes if we put a minus in there. Minus, minus, minus. We know cos A minus cos B, this part will go here, cos. But we have negative sine A, and then it's going to say minus plus, okay? Minus plus is minus. So it will be negative sine A minus sine A sine B again. We get equal to negative 2 sine A sine B. But I'm just going to write sine A sine B and take that negative 2 to the other side. It will become negative half, okay? And it's multiplying. So that's just it. And if we can do for the rest again, this is you maybe in the exam trying to remind yourself. You can have sine A plus B, and this would be equal to sine A cos B, okay, sine A cos B, and then minus cos A sine B, okay, and then if you have sine of A, so this is plus again, sorry, it's not a minus, but it's a plus, because we said if it's a plus inside for sine, it would be a plus again there. Now if we have sine A minus B, it would be equal to sine A cos B minus cos A sine B, all right? And that means if I say, okay, let me add these two to say plus, plus, it's going to be plus. Well, this side is going to be sine A, sine of A plus B, plus sine of A minus B, and then this will be equal to, this is sine A plus sine A cos B plus sine A cos B. It would be 2 sine A cos B. If we take that 2 to the other side, it will become half. Okay, so it will be half of sine A cos B. And we know that the cos A sine B positive minus the cos A sine B, they'll cancel, right? And then that's what we remain with. Okay, let's say we now have a subtraction sign. Let's see what we would then have if we had a subtraction sign there. Well, we would be having minus, minus, minus. Then this becomes sine of A plus B minus sine of A minus B, okay? And this would be equal to, if I say sine A cos B minus sine A cos B, it becomes 0. Then cos A sine B minus minus becomes plus. So plus cos A sine B, it becomes 2 cos A sine B. But I'm just going to write cos A sine B and take the 2 to the other side. It becomes half. And it multiplies everything that was there. So these are the formulae I'm going to use. Okay, I'm going to use formula number 1, number 2, this relationship, number 3, and number 4. So if I get an example that says, please find the integral. For example, it says, find the integral of, it says sine 3t cos, say sine 3t cos 2t, and it's with respect to t. Then what am I going to do? Well, I'm going to go and look for the one that has sine cos, okay? So sine A cos B, because you can see that 3t and 2t are not the same. So I'm going to look for sine A cos B, and I found it here. And what is it equal to? It's equal to half whatever. So I'm going to say this would be equal to the integral. You see, this you use it when you just have the angles, but you don't have them raised to any power. Okay, they're all raised just to power of 1. So here I can put the half outside, the half that's coming in, and then I'm going to have sine A plus B. So I would have sine of, I can see my A is 3t, so it would be 3t plus my B is 2t, okay? Because it's the B is what was on cos and the A is what was on sine. Doesn't matter which one exactly. So it would be 3t plus, so it's sine A plus B, and then plus sine of A minus B. And A is what's on sine, so it will be 3t minus B is what's on cos, minus 2t. And all this is with respect to t. So it is equal to half multiplying the integral of sine 3t plus 2t is 5t. Then plus sine 3t minus 2t is sine t, okay? Plus sine t, and all this is with respect to t. Okay, and it's equal to half multiplies the integral of sine 5t plus the integral of sine t. Okay, and this is with respect to t. Let me just put, this is actually with respect to t, and this is also with respect to t, and this all be multiplied by half, so it's just half. The integral of sine 5, what gives me sine is negative cos, because positive cos when I differentiate gives me negative sine. So what gives me positive sine is negative cos 5t, and I divide by that 5, which is the derivative of 5t. Then I say plus, okay, so there's a negative sign, never forget that. Half is multiplying that. I have the integral of sine t is again negative cos t, okay? And it's now equal to, it's now equal to half by that, it's now negative cos 5t over 2 times 5 is 10, okay, and then minus cos t, and this would be what you'd get or as your final answer. But there's one thing that you must never forget after integrating, and that's to add the constant of integration c, as long as it's an indefinite integral. So you then have to add the constant of integration c, and what you would have found here is the final solution. All right, bye.